Ladies and gentlemen, please welcome Google's Vice President of Product Management, Developer and Compute Platforms, Sam Ramsey.
Good morning. I can't tell you how thrilled we are that you're all here today. I hope you've had a great conference, and I hope we blow your socks off today with awesome technical content and lots of open source. So Next has been an amazing event so far, and it's been great to meet many of you in breakout sessions, in the hallways, and even on the street. The vision Diane Green shared on the first day of Next showcased the evolution of Google Cloud and how we're growing extremely quickly with enterprises and startups. Yesterday, Urs Holzle showed us many of the new releases and updates we've been working on with Google Cloud. This week alone, we've announced more than 30 new features and products that are now available for everyone to take advantage to build what's next. Now, today, we want to take time and talk about one of the things that fundamentally defines how Google approaches the cloud. Today, we want to talk about openness. To guide us through the combined journey of open source and Google is a person I've long admired, 5-time co-chair of OSCON, the world's greatest open source conference. She now leads open source communities for Google Cloud. Please join me in welcoming another badass woman, Sarah Novotny.
Good morning, folks. Openness is about sharing. Openness is about agreeing on common goals. And openness is about working together to make better software and a better world. Google's commitment to openness has helped us hire many engineers and allowed them to develop, contribute to, and support many of the technologies that are running the broader internet today. A 2004 white paper on MapReduce became the basis for many technologies underlying the big data ecosystem. Google's internal system, Borg, for managing containers, was reimagined as Kubernetes, an open source container orchestration system. These are some of the latest examples of collaboration where openness has involved our industry. We at Google are humbled that over 1 billion users take advantage of the services we provide to openly share their content and services, as well as their dreams and achievements. It's cliché to say, but we're standing on the shoulders of giants. All of this is possible because of those that started this journey toward an open world long before Google was an idea thought up by 2 grad students in Stanford in the late 90s. This morning, we'll hear from 6 speakers sharing particular facets and benefits of openness as a philosophy. Vince Cerf, Jim Emlyn, Eric Brewer, Chris Wright, and Jeff Dean, and Rajat Monga. This story will, I hope, underpin Google's commitment to open cloud and why it is so strong. As the internet was being created, one of the most important decisions was to create and use open standards and technologies to help ensure that the network was both resilient and easy to interconnect as new systems came online. It's this commitment to openness that opened a whole new world of interconnection and has enabled the internet to become a nearly universal means for exchange of code, information, services, and ideas. The decisions to make the internet based on open standards were fundamental to making it universal, just as the goals of open source and an open cloud are critical to creating the next generation of technical advances. Vince Cerf co-designed one of the key parts of the internet, TCP/IP. He worked with the group that helped connect the first 2 nodes to ARPANET, ran the Interneting Research Group and Development Program at DARPA from 1976 to 1982, and was later responsible for helping bring the first commercial email system to the internet. He's also responsible for helping form ICANN, was the first president of the Internet Society, and currently serves as a commissioner for the United Nations Broadband Commission for Digital Development. He is also working on the interplanetary internet with NASA's Jet Propulsion Laboratory. Here to share his experience and knowledge about how openness was a key design principle for today's modern internet is Vint Cerf.
Thank you, Sarah. Well, good morning, everyone. This is a wonderful opportunity to talk about the thread of openness which weaves itself throughout the internet story. So let's start. Can I get the first? There we are. Here's an example of a publication from 1974. I have the feeling some of you may not have been born then. This contained the description of the internet design. It was published openly by Bob Kahn and me in this publication. Our design intended to be available anywhere to everyone with no barriers. So we took no patents, we didn't make any intellectual property claims, and we did that on purpose because we wanted there to be absolutely no excuse not to adopt TCP/IP as an international standard. So openness was important to us from the get-go. The Request for Comment series, which I suspect many of you are familiar with, was started in 1969 by my colleague Steve Crocker, who now happens to be chairman of ICANN. Again, openness. The intent here was to make sure that everyone involved in the project and other people who were interested could see in detail how this stuff works, what the debates were about various choices. Again, open access to everyone. The internet itself has open characteristics, and most of you, I'm sure, are very familiar with that. At the core of the internet is the internet protocol. And it has this interesting property. It's stupid, right? It doesn't know, the packets of the internet don't know how they're being carried, no idea if it's going over a satellite link or an optical fiber, and it doesn't care, like a postcard doesn't care how it's being carried. And on top of everything else, the internet packets don't know what they're carrying, right? They have no idea. It's a bag of bits going from point A to point B with some probability greater than 0. That's all we ask of it. What's important is because they don't know what they're carrying, any information has to be interpreted at the edges of the net. This is part of the end-to-end principle. So the point here is that when you want to add a new application, you don't have to change the net. The net doesn't know. That's open with a big O. And so all the other protocols that you see going up towards the top and spreading out like this are evidence that if you aren't happy with the protocols that exist now, go build your own. If you're not happy with the underlying transport mechanisms, find another one. So this is open in every sense of the word, and that's why so many new applications have been developed over the last 30 some odd years of operation. Why does this thing, there we go. So here's an example at Google. We developed a new protocol called Quick that combines the TCP protocol with the TLS protocols and adds a few other features as well. And that just slips right in where TCP and TLS would normally go. And that runs right now in our browsers and in our servers and in other people's software who choose to use this particular idea. You might be surprised to know that we were playing around with packet voice and packet video in the 1970s. This is because the military knew it was going to have to use networking in order to carry voice, video, and data. We weren't carrying very much, though. I can tell you, our backbone speeds were 50 kilobits a second back. That was broadband. Now it's a dial-up modem. But we were experimenting with the concepts and actually trying this stuff out. The World Wide Web, of course, came along. Tim Berners-Lee invents this in the late 80s, early 90s, and is free to do it, right? He just invents a set of protocols, HTTP and HTML encoding, and he puts that up on the net. He doesn't have to get permission. The guys that started Google didn't have to get permission from somebody to go put up the service. They just put it up in their, I guess it was in their dorm room and then in a garage. Classic Silicon Valley story. But the whole point here is it's permissionless innovation, and that's what the internet has been about and is still about. And that's what's important to you, because if you're thinking about starting new businesses, you want to be free to invent. You don't want to have to get permission to try out your ideas. And of course, now you see all the mobile apps and cloud servers that are happening. Again, evidence of the permissionlessness of the internet. Here's another example. It's amazing. Everybody who got a browser and was curious, how the hell did they do that, had the opportunity to go look at the source code. Boy, that's open. Everyone had a chance to try out new ideas, steal ideas from everybody else. The whole point is that we grew the notion of webmaster from zero by people trying each other's code out and modifying it, trying other ideas, and those got shared and propagated almost organically. This is such a perfect example of why open is so important to everyone. There's another thing, and that has to do with the institutions that are part of the internet. We didn't create all of these at the same time. We created them when they were needed. So the Internet Architecture Board, which used to be called the Internet Configuration Control Board, when I was still in the Defense Department, I needed to have the people who were running the project get together and talk to each other about what was going on. I wanted this to be only the people I picked. So the name of this thing, Internet Configuration Control Board, was picked to be as boring as sounding as possible, so no one wanted to be on it except the people I put on it. That became the Internet Architecture Board, which spun out the Internet Engineering Task Force, where all of the standards get made now. The Internet Society was created in order to support the Internet Engineering Task Force when the National Science Foundation said, we don't want to spend any more research dollars on what has become a very active commercial kind of environment. So the Internet Society was formed to support IETF, and now, of course, it does a lot of other things as well. ICANN got created similarly around 1998 when the government decided, the US government decided, why are we pretending to be in charge of internet address allocation and domain name management and the tables for the internet, internet protocols? Why isn't that in the private sector? And so ICANN was created as a multi-stakeholder group, completely open. Anyone is allowed to participate and become part of the policy-making apparatus. Regional internet registries were created partly for convenience, to spread the workload. There are 5 of them around the world, and they hand out internet addresses to ISPs, who subsequently make those available to users. And more recently, the Internet Governance Forum spun out of the world's, what was called WSIS, the World Summit on the Information Society. This was originally a multilateral, intergovernmental thing. Very quickly, they discovered there was more to the internet than governments. It was people like you and me. And so that blew up into the Internet Governance Forum, a multi-stakeholder annual event, which now has regional events to go with it. All of this stuff is wide open. Anyone is allowed to participate, and you should too. Thank you very much.
Thanks, Vint. Now that we've established a long-standing history of openness as an underpinning philosophy behind our modern communications marvel, the internet, it's important to understand that adoption is how we've come to this place in history. To help us understand how open source has learned to balance the tensions between openness and business needs, I'd like to introduce Jim Zemlin, the Executive Director of the Linux Foundation. Please join me in welcoming Jim.
Thank you. Thank you. Wow. Following one of the fathers of the internet, big pressure. I'm old enough to have been around in 1974, but young enough to have still run a dial-up BBS, so I'm flattered to be here. And I'm honored to work at an organization that's home to one of the most successful open source projects in the world. And I don't need to convince this crowd how important open source is, but I want to remind you of how powerful open source is. I mean, just look at these statistics, at how far collaborative development has come. Tens of thousands of files, millions of lines of code, thousands of developers on just one open source project. And these stats are compelling, but this is my favorite statistic about Linux. 10,000 lines of code added, 5,000 lines of code removed, about 1,800 modified every single day. 365 days a year. There is no organization on earth that can independently keep up with the pace of development that's represented by modern open source processes. In fact, open source has become the new norm for software development. I mean, really, nobody builds anything these days without using open source code. You know, the internet is really built on open source, whether it's Google, Facebook, Amazon, you name it. It's all built on Linux and a variety of open source. In fact, it's more than a norm for software and the internet. Open has become a new economic norm, an incredibly important norm as we create more and more complex systems. That norm says something very, very simple, but has been written about in hundreds and hundreds of books. And the simple concept is, all of us are smarter than any one of us. And I would go so far as to argue that organizations, developers, anyone who does not harvest this great shared value, that doesn't participate in this collective innovation, will fail. And I have some good news for you. The good news is there's a lot of open source out there. I mean, look at this. Just on GitHub alone, there are 50 million open source repositories. And with this wealth of code and ideas and collaboration, one of the questions that I get all of the time is, which projects really matter? I mean, they're all great, but which projects can I bet my company on if I'm building a cloud? What can I bet my safety on if I'm using open source for an automobile system, which almost every modern production vehicle uses today? And we spend a lot of time at the Linux Foundation looking at that question. And our idea is that the answer to that question are that the open source projects that matter the most are those that have sustainable ecosystems, where a rich community solves a big problem, creates value. That value is consumed by companies like Google, Microsoft, Amazon, Facebook, who then create profit. Governments may save money, increase transparency, and then that value, in part, is harvested back into the project, which begets better code, lather, rinse, repeat. And that's what foundations like mine and the Apache Software Foundation and the Eclipse Foundation really do. You know, Vint talked about creating institutions when they needed them with the growth of the internet. We're creating the same kind of institutions to enable the growth of open source. And these institutions allow competitors and collaborators to trust each other by creating the institutions that enable that trust. A governance structure to make decisions, a development process that enables people to scale out development and sustain that development for a long time. Infrastructure, whether it's things like GitHub or the wide variety of version control systems, somebody needs to land a patch somewhere. That's what these organizations provide. Ecosystem development. How do you get more developers to the party? And then IP management. What license is the code under? Who owns the trademark? How do you govern the intellectual property sharing? How do you share what you want to share and keep what you want to keep? That's what organizations like mine and other institutions are doing. And open source projects that lean on these tend to be the most enduring. That's why last year, Google approached us and said, we would like to give up Kubernetes. We're going to give you the intellectual property assets, the trademark, and so forth. We're going to create a shared development model with our competitors. And since that happened, Kubernetes has been a rocket ship. It is on a trajectory similar to Linux in terms of becoming essentially the Linux of the cloud, in terms of the developer momentum, the number of pull requests times developers. It's an insanely fast-growing project. Which leads me to the last point, which is I work with over 1,000 organizations, largely companies all over the world. And companies don't come to me and ask about code. What's TensorFlow? I want to see the code. They ask me about how to share. The biggest problem in sharing, and this is the one thing you should remember from me today, is being a leader in open source takes work. The human aspect takes work. Being able to pull code in, modify that code, share that code back, takes a process. And Google is one of the masters of that process, and I want to tip my hat to Google. You know, you hear about the term Giphy. when Kubernetes was open sourced, it was Google for everybody else, right? Everyone could take advantage of this container technology and this great code. But one of the other insights I'd like to give you from observing Google in over a decade, working with people like Chris DeBone and Kat Allman and others in the open source program office, is code flows in and out of Google seamlessly. It's intentional. Learn it. And if you learn this, you'll be able to harvest that shared R&D and succeed. Thank you very much.
Thank you, Jim. It's wonderful to hear that Google is perceived as a positive influence in the open world, and I can't be happier to hear Kubernetes referred to as the Linux of the cloud. But moving on, Sam Ramsey, who we will hear from again later, frequently refers to open source and collaborative work as a positive-sum game. Google has seen this as a force multiplier and has been intentional and long-standing in our support of open source projects. Eric Brewer, the VP of Infrastructure and a professor at UC Berkeley, focuses on all aspects of internet-based systems, including cloud computing, scalability, containers, and storage. As a researcher, he's led projects on scalable servers, network infrastructure, IoT, and the CAP theorem. Today, I'm delighted to hear his thoughts on why an open cloud and open source investment is as important as an open internet was 40 years ago. Please join me in welcoming Eric Brewer.
Sarah. All right, fantastic to be here. Imagine that you are in a new market, and it's the next big thing, giant, giant, giant. But you have some really big competitors, and they have a multi-year head start on you. How are you going to compete? Well, that's what happened to Linux. These are projects that Google's contributed to for more than 10 years, a decade's worth of contribution in these projects alone. And in the case of Linux, 20 years ago, the next new thing was the web and internet services, and honestly, Linux was not a very good internet services operating system. Yahoo used BSD, Inktomi used Solaris, and they had a multi-year head start on Linux in this space. But Linux won. Why did Linux win? Linux won because it was open, but really because it had a higher rate of innovation. And so what matters is not where you start. What matters is your rate of innovation. Even in containers, where we had 10 years of contributions to Linux from Google, that started out as something simple to do kind of resource management, things like CPU sets, and then C groups, additions to the Linux kernel that allowed you to kind of manage your resources, and of course eventually led to Docker and Kubernetes, which is where we are today. Now, there's a whole other piece here, which is open source is the kind of leadership of an ecosystem. So you've probably heard of Android and Chrome. Those are open source projects created not for their source code, but for their ecosystems. The ecosystem is how you steer a large community in a collaborative way. And certainly in the cloud space, TensorFlow, which you'll hear about from Jeff Dean in a little bit, and Kubernetes are in this mold. We are aiming to create open ecosystems that have high rates of innovation. And if you know anything about Kubernetes, you know it has a super crazy high rate of innovation. Right? That's kind of the whole point. Other things on this list, like Bazel and gRPC, represent a different view, which is open source projects we created because we feel like there was a Google way of doing something internally that wasn't understood externally. gRPC is based on something called Stubby, and Bazel was based on an internal build system called Blaze, both of which we really like and we would like more people to use, right? And in particular, we'd like more people to contribute to and to understand and evolve. Now, that's another kind of open source. This is the leadership part. We take a little aside from it. You know those slides you make sometimes where you put a whole bunch of little text on it that nobody can read? And you do that because you want to show how many things there are? Well, look at all these screens. This is 1,000+ open source projects to which Googlers contributed in 2016. So I had to put in these extra screens to fit them all. Except that this is only 10% of the 15,000 that Googlers contributed to in 2016. 2,500 of those had extensive contributions, right? I would say, legitimate ongoing things that were evolving. And in total, again, just in 2016, 287,000 commits from Googlers using their google.com email addresses, meaning that's work-related, not counting the many, many thousands more that we don't know of, which are on their personal and Gmail accounts, right? This is stuff where we believe it's worth the investment to make these systems better, right? A fundamental different view on what we want to get out of this. There's another kind of open source support, which is actually just plain old financial. So these are foundations that we support directly, events. We run 50, or help run, fund 50 to 75 different kinds of events throughout the year, all over the world. This is also where things like Google Summer of Code fit, trying to expand the community of open source contributors. There's another kind of support as well, which is security. We live in a difficult time from a security viewpoint, and we have a shared fate, right? We are all using the same core pieces, and we will make it or not together, right? So an important kind of contribution is to improve the security of the world systems, and open source makes that significantly easier. So in the last few years, Google's fixed more than 100 security bugs in Linux and Chrome. And in December, we released a tool called Fuzz. And the purpose of Fuzz is essentially to allow you to do fuzz testing on your own code and improve your security. And in fact, it'll even help you make the right patch. So all this is to say that open matters to Google, but I'd go farther and say that open matters more for the cloud. Because in the cloud, we are on a joint mission to build the world's software, right? It is fundamentally collaborative. The collaboration is on the code, right? And so our strategy here is be the open cloud, have the faster rate of innovation, have more collaboration, right? Be the place where collaboration occurs. And it's not completely altruistic, right? When I got to Google 6 years ago, one of its challenges, which remains a little bit, but not as much, is that its internal systems, although they drew from many open source projects, were very exotic. They have their own little internal systems of ways to build things. When you'd come in as an outside developer, it was very difficult to be productive in the first 6 months. Because whatever you knew coming in, you had to learn different systems to make progress. As we move to open systems, things like Kubernetes and TensorFlow, Google benefits by being more like the rest of the world. That's a much more sustainable place to be. And so that's another reason we're embracing openness in a fundamental way. Let me close on one last thought, which is, in the end, the reason it matters to customers is, I think, is the freedom. And by freedom in this case, what I mean is that the same code runs on-prem and in Google Cloud. The same code runs on multiple clouds. And you can decide for your code when to run it on-prem, when to run it in the cloud. If you want to migrate to the cloud, you choose the timeline and you choose the steps. And if you don't like something, you can leave, right? Freedom means freedom to leave, but it also means freedom to join, right? So the strategy here is very simple. We're going to be the open cloud. We're going to innovate faster. We're going to give you the freedom to leave and the freedom to join, and I'll take my chances. Thank you. I'll go this way.
Open matters more for the cloud. That's a pretty powerful message. Co-development with our customers and our partners as a philosophical underpinning of the Google Cloud strategy. Hybrid and multi-cloud is not a waypoint on your journey, but a goal that empowers you and allows, while allowing and encouraging you, our customers, to choose the services which meet your needs. We want to support you and the tools you know and have, while allowing you to take advantage of the tooling and infrastructure that only Google can provide. This sort of collaboration with customers and partners through open source is something that Red Hat has a long history of doing well. Chris Wright, Vice President and Chief Technologist at Red Hat, has also worked for many of his 20 years directly on upstream open source technologies like Linux, Zen, KVM, OpenSwitch, and OpenStack. Today, he's going to share with us how collaboration, open source, and enterprises can work together to benefit the industry. It's my pleasure to introduce Chris Wright.
All right, really great to be here. It's unusual for me to be on a stage after hearing about the openness and introduction of the internet. So I'm excited to be here to share with you some of my thoughts and my experiences in open source collaboration and bringing that to the enterprise. So first, I'll start with a personal story. About 12 years ago, Brian Stevens, who was then at Red Hat, contacted me about joining Red Hat. And I was 100% focused on upstream development. I was definitely skeptical about what the relationship between commercialization and enterprise focus might do to my focus in terms of upstream. And so I came up with a list of reasons, all the reasons why I was going to say no. And Brian neutralized each one of those. I had one final reason, and that was my wife and I were expecting our first child. And I thought maybe two big changes at once isn't a great idea. But one thing really persisted and stuck with me, and that was the idea that I really like working with customers, understanding customer problems, and helping them solve their issues in the context of open source. That's exactly what we do at Red Hat. We spend our time with our customers distilling their requirements into upstream code, delivering that as products, really harnessing open source innovation to deliver the value of open source to the enterprise. So let's take a look. What is the enterprise? You look inside the enterprise, and it is a collection of highly heterogeneous systems that have evolved over long periods of time. Inside the enterprise is a bit of everything. You look at compute. You've got mainframe. You've got RISC Unix. You've got modern x86 and Linux. On the networking side, you've got switches and routers and server NICs from different vendors, different generations of technology, storage, fiber channel, Ethernet, direct attached. You've got different authentication from LDAP to Active Directory. You've got process change management, ISO and ITIL. All of this creates a complex system. And complex systems, with complexity comes fragility. The mission-critical nature of enterprise applications creates a risk-averse environment. And these siloed areas of expertise slows collaboration. So the enterprise data center is an artisan, handcrafted, special snowflake. The IT groups have been sort of relegated to a cost center with a mandate from CIOs to really reduce costs or do more for less. And here open source comes in, and something like Linux builds a standard platform, decoupling the hardware layer from the application layer. The industry-wide collaboration helps craft this core platform and adapt it to all of the unique requirements that you find in any one enterprise. Again, that's what we're doing with our customers. We're understanding those requirements. We're taking those into the upstream communities, developing code, and delivering those as products and supporting that with our customer. But the enterprise is changing. The business world is much more competitive today. Things are moving quickly, and it's software that differentiates businesses. The ability to adapt to market changes requires efficiency. You need to be able to build high-value software and deliver it quickly. In order to do that, you need to standardize and automate for both developers and operations efficiency. The enterprise is really looking to the web scale companies to understand how they can improve this efficiency. Building things out of microservice software architectures, using containers to package app services and direct dependencies, using CI/CD pipeline to deliver this into a hybrid cloud at cloud scale. Risk is mitigated by small incremental change, and those silos are broken down by cross-functional teams. So we built OpenShift to address those needs for our customers. And OpenShift, building this kind of modern web scale application platform, we built it out of low-level Linux container building blocks. So inside OpenShift, we had a unique to OpenShift implementation of containers and container orchestration. You could call it our own snowflake. Open source communities are really driving technology innovation. So you see containers go mainstream through tools like Docker. The experience from Borg captured and brought to mainstream by Kubernetes. And what we saw was an opportunity to take that innovation, rebase ourselves as OpenShift onto these mainstream projects, and deliver that value to our customers while being able to take on the rapid innovation in these communities that are much larger than ourselves. So letting go a little bit really gave us a huge lift. Today, we're not just contributing to OpenShift or Docker or Kubernetes, but we're contributing to the community at large, and we're contributing to our partners and competitors. We're helping GKE. We're helping other Kubernetes-based distributions. Our developers are thrilled by the success story and the contribution that they've had to something like Pokemon Go. What a cool story, and to know that you've been a part of that is a great brings a great sense of satisfaction. So open source collaboration benefits everyone. Diversity is a really important component of the communities that we're building here. And if you look to ecology, there's a lot of studies showing biodiversity creates a strong ecosystem. Here we're talking about diversity of users, diversity of developers, diversity of customers and vendors, diversity of use cases and requirements driven by these customers and vendors addressing different markets. And the end result in an open source collaborative community is continual refinement, code refactoring, architectural improvements to take on all those requirements, building a platform that is more maintainable and sustainable into the future, will continue over time to grow and change and adapt. And that is exactly what we're doing together today in communities like Kubernetes, and we look forward to continue doing that together. Thank you.
Collaboration and diversity of thought only make our projects stronger. Open source development in active communities enable perspectives that any one company developing a product cannot see. Working together makes open source platform and infrastructure software and projects stronger and more useful to a broader array of users. In addition to all the projects which Google has contributed to over its lifetime, there are hundreds of projects that Google has founded and maintains in a transparent manner. Chris mentioned one of our highlights. Kubernetes began as a company-led project and is growing toward community leadership. A few statistics on the Kubernetes project, again, my favorite, show the crazy level of engagement we have. While we have more than 1,000 code contributors over the lifetime of the project, there are many more ways to participate in open source. In February, more than 700 people commented on and created issues, offered pull requests and reviews, and generally participated in the Kubernetes project on GitHub alone. Beyond the sheer number of people who are participating, their engagement is unprecedented. Those 700 community members interacted with the Kubernetes project on GitHub an average of 15 times. If my math is correct, that's more than 10,000 events changing Kubernetes in February in GitHub alone. Beyond that, we have special interest groups, we have mailing lists. A conversation about Google's open source commitments wouldn't be complete without a view into another highly visible open source project. TensorFlow and Kubernetes compete for the top position for most engaged project most months. And here to correct me if TensorFlow is leading in March is our senior fellow from Google, Jeff Dean.
All right, thank you, Sarah. So I'm going to talk to you today about TensorFlow, which is a machine learning platform our group has been building to help support our research and to get machine learning systems deployed throughout Google. So I lead the Google Brain team, which is our artificial intelligence research team in Mountain View. And our group does long-term research, so we need a platform that's very flexible to allow us to express lots of different kinds of machine learning ideas, and also to interact with the machine learning community. We publish papers. So our group built an earlier system called Disbelief that we did not open source, and then we used that for a couple of years for our research and for some product uses. And then as we were thinking about what we wanted to do next, we took the ideas that were good about Disbelief, but also fixed a bunch of the things that we didn't like about it, and created TensorFlow. And from the beginning, I argued that we should open source TensorFlow and really make it a common platform for everyone in the world, not just people within Google. And so by open sourcing this, we actually allow lots of people to benefit from machine learning and being able to use machine learning in their products to do more advanced machine learning research and to really create a community around it. So why open source it? One of the things we like to do is publish research papers about our work. And by open sourcing sort of reference implementations of some of the code used to create the experiments in the papers, we allow people to more easily replicate our research. We also allow people to take those ideas and use them in their sort of product applications of machine learning. So things like computer vision models they can use in a lot of different ways in various products, either running on devices or running in the cloud. And we really want to bring machine learning to everyone. There's billions of people in the world, millions of developers who can benefit from using machine learning to accomplish things that are hard to accomplish other ways. So here's a graph of kind of the internal spread of machine learning and TensorFlow usage within Google. And one of the things we do is, as a team, is build this system so that everyone can benefit within Google. And we spread ideas. And as teams pick up machine learning, other teams see that and see that it would be applicable to their kinds of problems. And so you see it being used for many, many different things. There's about 4,000 directories now that contain TensorFlow configuration files within Google. So it's being used by hundreds or even thousands of teams. It's used in popular products like Gmail and YouTube and Translate, Search. And it's also, because we open sourced it, it's now the #1 machine learning repository on GitHub. And people have really taken to it as a way to express machine learning research ideas, to use machine learning code in their products in various ways. And just to show you what a ride it's been since we open sourced it, we open sourced it in November 2015. And this is a comparison with a bunch of other sort of open source machine learning projects, that most of which have been around for quite a bit longer. And we have a pretty engaged community, and that's really valuable to us. We're getting lots of good feedback, getting lots of information about what kinds of things we should be working on as a community. And I think one of the reasons it's gone well so far is that we've continued to innovate and create new and improved versions of TensorFlow and add features that people really request. So just to highlight a few, every couple of months we've been doing a minor version release. We just had our 1.0 release. And we released distributed TensorFlow, which was a big requested feature, added support for lots of platforms like iOS and Mac and Windows. Worked a lot on performance for our 1.0 release, which was last month. So That's been great. And the other thing that I think is really important is that it runs on lots of different platforms. We want machine learning to run wherever it needs to be run. That includes CPUs, GPUs, TPUs, our custom machine learning accelerator chips, Android, iOS, Raspberry Pi. All these things are important. So here to tell you more about the community that we've built up is Rajat Monga, who heads up our TensorFlow development efforts within our team. Thank you.
Thank you, Jeff. So Jeff talked about a number of things about TensorFlow. One of the most important things we feel about any open source project is the community. And you heard a lot of speakers earlier talk about this. So let's look at the great open source community that we have, with nearly 500 contributors from outside Google and many more within Google as well, and nearly 15,000 commits or updates to the source code over the last year, the last 14, 15 months. It's a very active project. There's lots going on, lots of development. It's one of the most active projects out there. We engage directly with the community. We look at the Stack Overflow. We work on, we have over 5,000 questions that have been answered by us and the community itself, and over 100 new community submitted issues that are responded to or fixed every single week. It's being used very widely in academia. So some of the top universities are using it for their machine learning courses. In fact, Stanford just offered a course specifically to train their students on TensorFlow so they could use it for all kinds of machine learning work. Jeff showed some of this. There are many different products at Google that use TensorFlow now. This is just some of them. So YouTube uses it for recommendations. Gmail uses it for spam. It's part of the cloud platform for the machine learning itself, and many other uses. Right. But open source was not just for Google, really. With that, we've made it available to many companies out there. And again, this is a small list of companies that are using it today. Many of these are building products for users like yourself or many others out there. It doesn't stop at these large companies, though. Machine learning is really for everyone. And there are many people out there who are just hobbyists or trying it out or trying to solve real problems. And this makes it possible for them to do it. Let's take a look at a few examples of what people have been doing with TensorFlow. So you might have seen this demo out there for cucumber sorting. So there's this cucumber farmer in Japan who has a large cucumber farm. And one of the things that needs to be done is once you have the cucumbers is sort them by size or shape. This used to be a manual work, roughly 8 hours a day, mostly done by the mother shown out there. And so the son decided, OK, let's see if we can automate some of this. So he took a whole bunch of pictures of these cucumbers, downloaded TensorFlow, trained a model to identify and sort them, and then ran it on a Raspberry Pi, connected it to an Arduino, and just automated that whole process all by himself. Pretty amazing use of TensorFlow. Thank you. Thank you. Machine learning is becoming very important for healthcare. And here I just wanted to show a couple of examples how it's being used in healthcare. So the one on the left is a Nature article for something that was done at Stanford by students there who, again, collected a whole bunch of pictures about skin lesions and which separated them from, OK, these are cancerous, these are not, trained a neural network to learn from that and identify which ones are cancerous. And they actually have a model that performs nearly as well as dermatologists, so it can be great for users. Another example is, in our team, we looked at pictures of the eye, the fundal images that you see on the right, and again, trying to identify if a user has diabetic retinopathy or not. And again, once you collect a data set, train a model, it ends up doing really, really well. So if you see how many doctors there are in the world and how many patients there are, there's no way we can, we don't have enough doctors to reach every patient. And this is a great way that machine learning can really help people who have no chance of getting access to doctors today. Thank you.
Thanks, Jeff and Rajat. I have to say, your community has done some amazing things I would never have expected with the TensorFlow platform. Cucumbers? That creativity is one of my favorite second-order effects of open development in open communities. Open development is both a benefit and a responsibility with a tight feedback loop. I mentioned that open development and a commitment to open source is also a draw to good developers. I count our new VP, Sam Ramsey, among those who were drawn to Google because of a commitment to openness. Please join me in welcoming the former CEO of Apogee and Cloud Foundry Foundation, here to share his vision on open development, Sam Ramsey.
All right. How are we doing so far? Pretty awesome? Not totally sure what I'm doing on the same stage as the inventor of the internet, inventor of Kubernetes, inventor of TensorFlow. But I thought I'd take a minute and offer sort of my frame. Like, how do I think about this stuff? How does Google think about openness? We think this is the best time in history to be a developer. Our craft is respected, our work has been elevated, and we're in an era of rising demand. This is our time. Now, as companies have realized they have to become digital businesses, they have figured out that this transformation is powered by developers. So as much as this is our time, the stakes are high. We have responsibilities to our craft, to each other, and to the world that developers never had before. High among them is the need to create systems that are secure, flexible, and open. Late last year, I came to Google Cloud because I felt there was no better way, no better place to make real all of the good that open source promises and take it further in a way that can impact all the places software is going, with what we call the open cloud. Our tools, your systems have to make sense. They have to be connected to be efficient. They have to be open so we can shape them how we need them to be. We can create the age of open development. Now, open development demands openness in every dimension. Open APIs, open source, and open clouds. When we have access to every part of our technology environment, we can build the system we require to develop at the speed we need. Openness lets us make unexpected combinations. So for example, both Cloud Foundry and Kubernetes are inspired by Google's Borg, and we started to see these communities come together around a project called the Open Service Broker API that lets Cloud Foundry and Kubernetes deployed applications call each other, discover and consume each other's services. Now recently, users who have deep investments in Cloud Foundry asked for a way to run Kubernetes on top of BOSH. That's tooling that they're already comfortable with that sits under CF. Now, engineers from Pivotal and Google took this to heart, worked with the customers requesting the capability, and made the necessary updates to BOSH. This new tool set is packaged as Kubo, Kubernetes on BOSH, and today, Kubo is open. It's pre-alpha open source on GitHub, available today. I expect more Cloud Foundry installations will look to add Kubernetes to their environments. Now, to quote Sarah Novotny, this is composable infrastructure at its finest. Applications written with open principles help us, however much is possible, reason about, and future-proof our applications. Think about this. Everyday critical information and logic is accessed from and poured into a wide variety of legacy systems built years ago using proprietary protocols. They weren't all following Vint Cerf's advice to start open and stay open. So whatever we build today is actually tomorrow's legacy. One of my favorite job titles I've ever read was in a book called A Fire Upon the Deep. Anybody read A Fire Upon the Deep? Werner Vinge, brilliant book, recommended to me by Jeremy Allyson, who's the maintainer of Samba. It's set tens of thousands of years from now, and the story is built on interstellar travel, but without breaking light speed, so they use cold sleep, and the ships have to last thousands of years. Now, of course, these ships are massively automated through software, and new software is constantly being written to solve new problems. For the really old problems, the boring problems, like core life support systems, they have really old software. What's the job title? Programmer archaeologist. So let's have some empathy for the developers who will come after us, right, and build our applications to be open to the future. There's also an element here of software as oral history, to quote James Governor. And we need to keep sharing ideas about the code we write as much as we share the code we write. So we have valuable but old applications stuck on old hardware. And we have new and future legacy applications that we run on elastic platforms like Kubernetes and Google Cloud. And we have data that drives those applications and results from those applications, both input and output. Generally, that data is wherever the applications are and shares the same constraints. We also have new modes of computing that are far from the desktop. Even mobile clients and the apps on those are starting to look like old hat. We're getting data from light bulbs. We're running apps on oil rigs and in surgery centers. and we're trying to make sense of all of it with analytics. For the really hard analysis problems, we're using machine learning. Now, I graduated in 1994 with a degree focused on AI and neuroscience. If you said AI back then, you went to the back of the hiring queue. It was the AI winter. So for a while, we concealed it under the safer heading of machine learning. But as Fei-Fei Li said on Wednesday, the AI winter is open, and it is time for the democratization of AI. Long live AI. So finally, we've got the product managers, the marketing managers, and the analysts who are all trying to figure out if this thing is working, right? Is this just technology, or is this really business? You know, the proof, as they say, is in the spreadsheet. So we even need to make these systems open to spreadsheets so we can bring those users on board, because business users matter too. Open development is the pattern we see everyone heading towards. It's made out of open APIs, open source, and open clouds. APIs are everywhere. We use them to get to modern services like Twilio and BigQuery. We roll our own over our own custom microservices, and we wrap them around legacy systems like general ledgers and mainframes. They have to be open to be really useful. They have to be openly documented using standards like the Open API spec. They have to use open protocols like HTTP and gRPC. They have to use open formats, often JSON, but sometimes XML. Open APIs have to be available to be called from anywhere, not just by code running in the API provider's cloud. Think about that. You should be able to call that anywhere in case you have to move your workload later. And if you're looking for the business angle, researchers like Marshall Van Alstyne at the MIT Initiative on the Digital Economy have even demonstrated that businesses with open APIs grow faster and are more profitable. So open source is a modern developer's basic expectation and the default licensing model for nearly all development tools. Open source is a positive-sum game where no one needs to lose in order for someone else to win. As Eric, Jeff, and Rajat showed, at Google we believe in offering technical ideas as open source, like Angular, Android, V8, Go, gRPC, Apache Beam, Kubernetes, and TensorFlow. And really important, we believe in giving back to open source projects where we have something to contribute and where we've received so much value, like Linux, KVM, MySQL, Python, Apache, Eclipse, Node.js, Samba, and many others. And additionally, we give opportunities to high school and college students every year to build open source projects while being mentored by open source developers and luminaries in 2 programs, Google Summer of Code and Google Code In. This is, to quote Jim Zemlin, the new normal, open source. Altogether, this is what we need for open development. Now, when I met Brian Stevens last year, the thing he said that made me stop and fundamentally reassess Google's cloud was this simple statement: we are building an open cloud. That's our strategy. I was kind of stunned. I had to dig deeper, and you can see where my exploration led me. In hindsight, I really shouldn't have been surprised, because Brian spent 14 years at DEC building open systems and another 14 years at Red Hat making Linux the enterprise standard. Open clouds are the new idea in this stack. So if we're doing open development on open APIs and open source, shouldn't we want an open cloud? About 6 years ago at OSCON in 2011, I and several other people started a nonprofit called the Open Cloud Initiative. We could see the coming era of cloud computing bringing a Pandora's box of exclusion and lock-in, and that the open source definition didn't guide the cloud. The nonprofit wound down, but the ideas live on. Users win in an open cloud. So an open cloud is open source friendly. It's both accepting open source and giving back to it. We aim to be the best place to run open source stacks. We're contributing to open source cloud computing projects, including core technologies like Kubernetes and TensorFlow, and working with Docker, Cloud Foundry, and OpenStack. We thank Chris Wright and the Red Hat team for helping us see the value in collaboratively developing Kubernetes. An open cloud supports open access with no barriers to entry or exit. You should be able to bring your own artifacts, VMs, containers, language, runtime, and framework. You should be able to take your things out as Docker containers, YAML files, and standard databases. You should be able to sign in with OAuth. You should be able to connect with enterprise and social identities. You should be able to see the logs of everything that's happened. Access transparency is crucial. And finally, an open cloud is home to an open ecosystem, plugging the platform developer community directly into the providers of all kinds of services. Now let me pause here. This is important. So services built by communities and companies should get all the same representation and distribution as services built by the cloud provider. Open innovation means open to a world of ideas and not assuming that our implementation of Cassandra or Postgres is the best possible one. So there's a big idea in here that could help democratize enterprise software the way that smartphones democratized consumer software. More services, each excellent, smaller in scope, built profitably by smaller teams. So I think if we work on this together, we can get the software industry to something sleek, adaptable, and sustainable. Finally, developers are tying all of these things together into the systems they need to work at speed, systems of continuous integration and continuous deployment. It's the on-ramp to everything good in modern software development, developers taking responsible for testing and production. It goes without saying that they're using open source tools like Chef, Ansible, Puppet, Salt, Cloud Foundry, GitLab, Jenkins, Concourse, and Spinnaker. This is a Concourse screenshot. And today, these systems are unique to each enterprise. They're as unique as your nervous system, and often unique to each development team. In the future, we may see common patterns emerge that we can simplify and standardize. So at Google, we want everyone to benefit from an open cloud. So to help make that possible, today we're announcing an expansion of our Google Cloud Platform free offerings. So first, your credits will last for a year. Second, we will have a level of compute, storage, messaging, and serverless that will always be free. But most importantly, we are walking our talk about the open ecosystem. You can spend your credits on our ecosystem partners through the Google Cloud Launcher. We will pay developers who built these services for your trial experience because your platform is our whole ecosystem. This is what open development looks like to us. So, open APIs, open source, and open cloud. We believe in open collaboration, working engineer to engineer. We're moving from just writing papers about Borg and Bigtable to actually sharing the code. We're writing books on systems reliability engineering. And we want to move the state of the art forward in both development and operations, which together make up the discipline of engineering. We're deploying our engineers to work directly with you on your critical projects. So we expect you to hold us accountable to this vision. Let me make a point. Negative feedback is a gift. It's a declaration of what's missing, like negative space. It says, this is missing, but if Platform had this, it would be awesome. So let me close by saying, we're glad you're here. I'm glad you're here. Let's build great things. Thank you. So it's my great pleasure to welcome my friend and colleague, Allyson Wagon. She's the Chief Marketing Officer of Google Cloud, and one of the awesome parts of my job is I get to work with Allyson every day. Please welcome Allyson.
Thank you. That was awesome. Good morning. Welcome. Thank you for being here. I'm humbled and privileged to be able to bring to market the incredible technology that my colleagues and others have been building over decades, building with the open cloud community. We're now going to transition to the second part of our program this morning, where we have the opportunity to hear from 3 great startups that are doing really interesting work, engaging with the community, and building on Google Cloud and with Google Cloud. First, we'll have the opportunity to hear from Will Marshall, founder and CEO of Planet, doing incredible work using satellite imagery. Second, we'll hear from Willem, founder and CEO of Odin Technologies, who's really transforming manufacturing with the democratization of AI. And third, Herman, the CEO of Improbable, will share great work they're doing. It's a London-based company with simulations in gaming and virtual worlds. So now please join me in welcoming Will to the stage.
Good morning. My name's Will Marshall. I'm the CEO and co-founder of Planet. And Planet's mission is to image every point on the Earth's surface and make change visible, accessible, and actionable. We do this with a network of over 100 satellites that we've designed, built, and operate in space today. In fact, today, Planet operates the largest fleet of satellites in human history. Unlike traditional satellites, ours are much smaller. And in fact, we've built 13 different iterations of these satellites and launched them on 13 different rockets over the last few years to constantly improve our capability in space. We call this agile aerospace. And a few weeks ago, we launched our latest fleet of 88 satellites on this rocket.
Last 25 seconds.
It's the largest number of satellites ever deployed from a rocket in human history. It was pretty nerve-wracking, but freaking cool. Thank you. But as cool as space stuff is, and I could geek out all day, that's not what I'm here to talk about. You see, the satellites for us are our back end. What they enable is what's really important, and that's the data that they can produce, and particularly the imagery. See, traditional satellite imagery you find online is old, and with the 149 satellites that we operate today in space, we have the capacity to image every point on the land area of the Earth every single day and see change as it happens. We see every port, every city, every farm, every forest across the whole Earth every day. And at the highest level, this data is useful for many things, but at the highest level, it's useful for us to help take care of our changing planet. Here are a couple of images so you get a sense for what we can see. Here's an oil refinery. You can see ships, you can see roads, you can see buildings, you can see individual trees. Here you can see another port area. You can just about see vehicles on roads, but you can't see people or read number plates. This is about wide-scale change. But our capability is being enhanced because we recently announced that we're going to be acquiring Terabella, Google's satellite arm, and with which we will be gaining 7 and soon 13 high-resolution satellites in orbit to complement this. And in fact, the satellites, the medium res and the high-resolution satellite data is very complementary. So what does this all mean? Well, for one thing, it means a shed ton of data. And dramatically increasing amounts every single day, terabytes coming down, documenting changes around our planet. And we need to get this data quickly and reliably to our users. And so yesterday, we were pleased to announce that we have switched to Google Cloud to host our imagery and do our data processing. And whilst there's a handful of companies that can offer storage and processing, we were really impressed by Google Cloud's core technology, especially the machine learning trajectory in both hardware and software that we think will be very useful, as well as the deep understanding of geospatial data. And I'd like to thank the senior leadership team at Google Cloud, as well as, in particular, Diane Green, for working with them. But this leads to our important announcement today. You see, at Planet, we believe our imagery should be available to everyone, not just the big companies and governments that have accessed satellite imagery to date. And so, if we can advance the slide, one more. That's why I'm excited today to announce the release of Planet Explorer Beta. We want to get data into the hands of individuals, small and medium-sized businesses, NGOs, developers, researchers around the planet. Planet Explorer Beta is the first global platform updated every month with imagery of the entire planet, no login required. Planet Explorer enables us to see the time element to satellite imagery. Let me show you how it works. Anyone who goes to planet.com can view our images on a monthly and quarterly basis. Each global base map is made up of millions, literally millions, of individual satellite imageries that we've stitched together. Using the timeline, you can navigate quickly across the world in space and in time. To date, satellite maps have been static, and we've changed that. Planet has added the time axis to maps. That's the key difference. Let's take a look at Gilroy in California to zoom in and see a little bit closer what you can see. So if we zoom in here, When you zoom in, you can see changes on a much more granular level. You can see, in this case, the fields changing with the various harvesting processes in these fields. But there's more. Once you log in, and you can do so with a free account, you can see a full set of imagery. We have taken imagery, one second. We've taken, on average, more than 150 images of every point on the land area of the Earth's surface. And you can browse this full stack of imagery with a free account. You can see those new images as they come down by day by day. And you can compare changes as they happen with a change tool that enables you to see changes as they happen day by day, like in Gilroy seeing the changes in the flooding. Planet Explorer enables us to easily visualize change and compare and see the changes that happens around the planet. There are limits. Planet at the present time is limited in zoom outside the US, and the imagery is available on our browser for personal and non-commercial use. We encourage commercial use, of course, but for that you have to sign up for a paid account. And then you can download our full imagery at full resolution. Now, there are zillions of use cases of this data, which is why we've created an open API to build applications on top of it. Here's a few examples. Imagine on a commercial side, you can count ships into and out of ports. In this case, ships into and out of the port of Sydney. You can track deforestation and even measure carbon stocks, here, in this case, in Bolivia. Earlier this week, our partners Descartes Lab released Geo Visual Search. Here, a user highlights a feature, and then it goes ahead and finds those features across our whole imagery. In this case, solar arrays in a whole of China. It's pretty freaking cool. Our partners and developers are building apps on our geospatial data, and we want to grow this community, which is why I'm here today to invite you to come and join our global community of developers. With Planet Explorer Beta running on Google Cloud, Planet is now delivering powerful insights about our changing planet, made available online at your fingertips. The goal of this is to enable users to browse our imagery and explore how it can help their needs. We hope that it will lead to more commercial partnerships, more benefits on the humanitarian side. You've been used to static maps, and Planet Explorer, you now get the real view, which is a constantly changing planet. Planet has added the time axis to maps, and anyone can come to planet.com today to view that imagery. We invite you to come and explore with us. Thank you very much. And now I'm introducing Willem from Odin Technologies, who's going to join us on stage.
Hi, my name is Willem Sundblad. I'm co-founder and CEO of Odin Technologies. I'm here to talk about the most important sector in the US economy, manufacturing. In 2015, gross output of US factories was $6.2 trillion, or 36% of GDP. It's easy to forget that the car you drive, be it a Volvo, Ford, Tesla, is not just built by Volvo, Ford, and Tesla. It's made up of some 30,000 components coming from a complex network of manufacturing suppliers. These manufacturers, they make everything that we take for granted in our daily lives. But they have not seen the benefits of the technological advancements that have happened in the computer industry and our consumer lives in the past 15, 20 years. Take the US plastics industry as an example. 16,000 factories, output of about $370 billion. But most of the data they collect and analyze to continuously improve their production is done with clipboards and timers, pen and paper. Now, I'm not saying that there isn't industrial technology, but it hasn't been accessible to the wider audience. It's only been accessible to the 1% of manufacturers. Most of the hardware is built on programmable logic controllers. Almost all software is hosted locally. Design of it looks like it's from the 90s at best, 80s if you're less lucky. And it's always been extremely expensive and can take months to years to implement even. But it doesn't have to be that way anymore. Through the ubiquity of networks, drastic decrease in cost of electronics and cloud computing, coupled with a tremendous growth in power and tools that are available, superior technology is now accessible by manufacturers large and small and in all verticals. We founded Odin with a core mission to empower manufacturers with data and tools so they can eliminate waste in their production, decrease scrap rates, decrease machine failures and unplanned downtime, understand their settings and minimize their material consumption so that every manufacturer can make the most of their capacity and make awesome products for us. To do this, we built a device based on the Raspberry Pi that can communicate with most industrial machinery and external sensors, take data in real time, send it to our cloud-based analytics platform. The data that we're collecting can be granular information about how the material is behaving throughout the process, what's happening inside of the machine, but also higher-level metrics like what's the throughput per hour, per RPM, per horsepower, what's the utilization of your production lines or your whole factories. And we do this built and hosted completely on Google Cloud Platform. The millions and millions of data points that we collect per production line per day is ingested with PubSub. Our real-time stream processing framework, where we can do complex transformations on the data, lives in Container Engine. We're about to move that to Dataflow. Storage, Bigtable, and the microservices that support our platform all lives in Container Engine. And the web application itself, Compute Engine. So manufacturers get real-time stream of all the important metrics coming from their production lines so they can take better decisions in real time, higher-level overview of whole production of lines or multiple factories on your utilization, state, throughput, what products you're making, complete traceability. You can search through product, time, events, so engineers and execs can solve problems, quality failures, machine failures, in minutes instead of weeks or months. And also, of course, label and classify the data in different states so they can share and collaborate, but also build up machine learning models so we can take them even a step further on making things more efficiently, making things better. In the same way that we build tools and capabilities that allows our customers, the men and women on the factory floors every day, build better products and run their factories more efficiently, Google Cloud builds products and tools that allows us to build better products faster and run our operations more efficiently. We probably wouldn't feel comfortable scaling up to thousands and thousands of factories with tens of thousands of machines all streaming data if we didn't know we had the infrastructure of Google to allow us to do that. And with that said, I want to hand over to Herman from Improbable and say thank you.
Hello. It's an absolute pleasure to be here. So if we want to build massive, gigantic simulations of virtual worlds or completely new ways of modeling cities or cells or economies, huge simulations that run on thousands of cores, it's a real challenge today. It's something that previously has only really been available to people with supercomputers. And it generally presents a very challenging programming model for developers. You've got to manage servers. You've got to cope with the synchronization of information. You've got to do so many things beyond just building your application. So at Improbable, we've built a distributed operating system we call Spatial OS that runs on Google Cloud and makes it possible to build these kinds of applications. Exactly the types of virtual worlds and massive simulations that we've all dreamed of, but put into the hands of developers so that it can be iterated on and built quickly and efficiently. And at the end of last year, we announced a massive innovation program with Google, which makes it almost completely free for hundreds of game studios to build completely new applications on top of Spatial OS. And though this first program was targeted at gaming, and it's only been a couple months, there's been an enormous number of really cool products produced, and I want to show you some examples of some of those. These include virtual worlds like Worlds Adrift that are 2,000 square kilometers in size. Worlds with their own ecologies. Worlds with massive numbers of players sharing the same space. No more sharding, no more separation. Experiences that in many cases have been built by teams of 3 or 5 developers. And our beta is live and active right now. And with the community, we're continually improving and adding to what SpatialOS can do for gaming. But today, I'm actually here to talk to you about the next step, the really big, significant, and important problems, which in one moment we will soon be able to talk about. Slide transition. There we go. So thinking about large-scale simulation as a way of solving problems, a good way to begin is to think about an example. Think about the most important decision that a company or a government makes, right? Let's take an example of what that could look like. Imagine thinking about how to change a massive cellular network that spans an entire city or a country. Any change you might think of making, whether it's a modification to the infrastructure, a change to a protocol, or an alteration in policy, is going to have millions of cascading effects, which are incredibly difficult to comprehend or think about. And the reason for this is that we're dealing really with emergent systems. And this is an idea I want to put across today. The idea that our world, the cells in your body, our economies, the big infrastructure that we build together, they all represent millions of complex emergent systems. And if we really want to understand these systems, we have to go a lot further than just using machine learning or past data. We need to learn to completely recreate these systems in their entirety. I mean, actually replicating entire cities on massive simulations, building models of these networks that have never been possible before. This is a gigantic and daunting technical challenge. It can't be solved through large-scale parallel systems. We need to build new kinds of semi-parallel distributed systems that can make this stuff work. And if we really want to change our world, we need developers like you to be able to run these systems in real time, build new businesses, and build new services that run on top of this stuff. And that's precisely what we've been doing with SpatialOS. And I'm pleased to announce that we're going to be open sourcing more and more content and showing more and more frameworks over the course of the next 6 months that are going to make it possible for more developers to attack new problem domains. And just like Google, with the spirit of open development and sharing content, we intend to do everything we can to foster a community where developers can share code, share frameworks, share integrations, and start to build and create new services and businesses. We don't all have to start from scratch. We can start to create an ecosystem to make this stuff possible. And that's why we've chosen to partner with Google. We truly believe that the cloud is not going to be a zero-sum game. The age of closed systems and trying to, in effect, hothouse developers into committing to a closed ecosystem are over. We can't succeed unless you succeed, and I think Google recognizes that. And that's the genuine reason why I'm here today and why we've chosen to make this partnership happen. We're also going to be announcing incredible new integrations with services, ranging from machine learning simulations that can be added into our tech to integrations with services like YouTube, which we'll be talking more about this year, that are going to make our technology even more functional and even more useful to you. So I've talked a lot about what's possible, but I haven't shown you anything really cool yet. So I want to show you something that we built in conjunction with the UK government. And it's been pretty secret until just basically this week, and I'm finally able to show it to you. This is the largest simulation of its kind ever created. This is a complete simulation of an entire UK city. Its telco network, its power grid, its transport network, its sewage systems, its housing demographics, even the way in which people move around and interact with the city. We're going to be open sourcing some of this content later this year. This runs on thousands of cores, and it's able to run in real time using Unity for visualization and interaction with the simulation. This has already started to transform the ways we look at cascading failure in emergent systems, change how we do infrastructure planning, change how we think about running services. And my contention to you today is that this is the future for how we're going to look at how all the systems in our world operate. Not just looking at past data, but recreating them, rethinking how we can make these what-if decisions. There's even companies that are beginning to use spatial to run systems of autonomous vehicles, being able to manage them as fleets. So I want to leave you with an idea. This thing here, AI, Google talks about it all the time. You can't go on TechCrunch without seeing an AI article. But this idea, recreating reality, building reality-scale simulations and services is just as important. And I believe it's going to underpin how our world is going to transform, whether it's simulations of tumors in cells that can help us understand disease, or models of infrastructure that can help us save money and make better choices. So with your help and the ability to build an open community on our technology, we hope to kickstart this. If you're excited, please check out what we have online. You can download our SDK right now and get started making games. Thank you.
Did he invite me on? Okay. Hi. Let's give a round of applause to Will, Willem, and Herman, who are doing such great work at Google Cloud. If you were here on Wednesday, you probably heard one of our many exciting announcements, that we at Google have acquired Kaggle. So I am thrilled to be able to invite the CEO on stage with us now to share a few thoughts about what that means. Please join me in welcoming Anthony Goldblum. Hey, Anthony, thank you. So Anthony, when we first met a couple of years ago, we talked about Kaggle as being this great place for machine learning competition. And then when we connected more recently, I got to learn about some of the great new innovations and where the company is going. Can you share a little bit about the evolution of Kaggle?
Yeah, sure. So, Allyson, as you said, Kaggle started out running machine learning competitions, and still I suspect that is the thing we're most well known for. But our vision for Kaggle is to become much bigger. We want to be the place where data scientists do all of their data science. So in August last year, we launched an open data platform. So this is a place, we have a very large community, and this is a place where they can share and collaborate on open data sets. And so people in our community will publish data sets through this platform. We have everything from very granular real estate data sets from around the US through to, I think we have data sets on all contestants for the first 21 seasons of The Bachelorette, all their profiles. So it turns out our users have very eclectic tastes. The other thing we have launched is a platform called Kaggle Kernels for reproducible data science. So this allows data scientists to train models using R or Python and share them in an easily reproducible way. So if you wanted to predict who's going to win season 22 of The Bachelorette, rather than starting with a blinking cursor, you can go and see what others in our community have already done.
That's so great. I love how kernels are really a great evolution of Kaggle, and I'm excited to see how the community will now engage with that. I know all of us at Google are very excited to have you as part of our team, and I'm interested to hear from you about what it means to Kaggle to be part of Google.
Absolutely. I think this is going to be huge for our community. So if you think about machine learning, historically machine learning has, well, first of all, we have a very large community. It's about 850,000. They share lots of data sets and lots of Kaggle kernels, so a lot of code within Kaggle. But if you look at where machine learning was a few years ago, or data science, it was mostly training models like logistic regression and random forest, which you can easily do on a single machine. Machine learning has really evolved. It's far more sophisticated now, and we can do much, much more powerful things. But our community, so in joining with Google, we give our community access to the world's most advanced machine learning cloud. And so we're going to enable far more, our community to do far more powerful things. So I think it's going to be a very exciting journey with you guys.
Well, thank you so much. I'm really looking forward to working together.
Thank you very much.
Thank you. So we believe that competition inspires creativity. And in that spirit, I have one final announcement to make here at Google Cloud Next. We are announcing a machine learning startup competition so that we can work with all of you to think about how we can continue to grow and build and create great companies. So what does that mean? Well, here is the entry criteria. This competition is open to early-stage startups. As the name would suggest, all implementing machine learning, but not just Google Cloud's machine learning, but any machine learning in our spirit of openness. And finally, this is open to any vertical, from energy to retail to healthcare. We are excited to work with startups of all kinds and in all spaces, thinking about how to leverage machine learning to build great things. And as for the prizes, there's two sets of prizes. The first from Google. So Google is going to be offering up to $1 million of GCP credits. Actually, not up to 1 million, $1 million of GCP credits to the winner. In addition, we are offering the opportunity to work one-on-one with our Google engineers to continue to build and tune your models. And of course, G Suite seats. But beyond Google's prizes, I'm excited that we have prizes from another community. And that's VC partners. We've teamed up with 7 great firms, Sequoia, Kleiner Perkins, GV, Data Collective, Emergence Capital, Andreessen Horowitz, and Greylock Partners, who are all providing support in connection with this competition. And hot off the press, 2 of these firms have now stepped forward, Data Collective and Emergence Capital, to offer investments to the winner. So each of these firms is planning to offer $500,000 to the winner of this startup competition. So now I'm pleased to welcome on stage partners from each of these firms, Santi Subotovsky from Emergence Capital and Matt Acco from Data Collective, who are going to share a little bit about what they're looking for when they think about machine learning startups. Please join me in welcoming Santi and Matt. Matt, great to have you here. Hey, Santi. First of all, thank you for teaming up with us. I'm really excited about this competition. As you know, I have a background in venture, and I love working with early stage companies. All of us do at Google. And so I wanted to give each of you an opportunity to share what you're excited about and what you're looking for in these early stage ML companies. Matt, let's start with you.
OK, so to understand what we're looking for, first you have to understand a little bit about our firm. VCs are fond of saying we manage $10 billion, or we were the first investors in Genentech or something like that. I'll simplify it. We have a double handful of partners who invest in us. Our limited partners, they aggregate about $1 trillion of liquid capital, and they entrust us with a reasonable percentage of that to back ambitious ideas from folks like yourself. What we're looking for, broadly, are people attempting the impossible. We're not interested in apps. We're not interested in widgets. We invest in what's colloquially known as deep tech. And to give you a sense of that, I grew up in a dark, desperate, polluted time, no, not today, the 1970s, when a 1 megahertz processor was a thing of wonder and 16K of RAM was a blessing. I watched my great uncle spend a year at Stanford sequencing a single gene. When the space shuttle launched, even when it rolled out of the hangar with the word Enterprise on it, my nerd's heart leapt with joy. These were crude, painful things relative to what we have in hand now. And thanks to Moore's Law, thanks to a self-reinforcing virtuous cycle of algorithmic innovation, we have the ability to exponentially go beyond what I grew up with, what was true in the past. We're looking for people who apply deep compute, deep tech, novel algorithms, proprietary data to attack the impossible in gigantic industries and create multi-decade monopolies. That's how we make our money, but that's also, as hackneyed as this phrase may be, make the world a better place. And what we're looking for is people who will accept that challenge, will rise to that challenge, and make something great.
Thank you so much, Matt.
So, thank you, Allyson. And we're super thrilled to be partnering with Google and with Data Collective on this competition. Just to give you a little background, at Emergence, we've been investing in enterprise cloud companies for the last 15 years. And as early believers, we saw this massive tectonic shift from client server to the cloud. Now we believe we're starting to see another massive change with artificial intelligence and machine learning. And it's going to happen in the next 10 years, and we believe it's going to affect every process within enterprises. And the way we think about this is most enterprise cloud companies are taking workflows and moving them to the cloud. With machine learning and artificial intelligence, we feel that we can start bending those workflows and closing the loop and creating what we call a coaching cloud, where you can close the loop, and automatically the system gets better and better every time a new workflow is being processed. We're excited because we believe that that has the potential of disrupting the now incumbents of the cloud if they don't move fast enough. And that's what we like to do. I mean, we like to build great things with our entrepreneurs. And in terms of the areas where we see this happening, just think about where there's a ton of data and where there's human interaction. Think of, I don't know, low-hanging fruit, CRM, customer success, marketing, ton of data and a lot of repeated processes that should be getting better and better automatically as you close this loop. And we're also excited because we did something similar 10 years ago, and the winner of that competition was a company called ServiceMax that recently got acquired by GE for about $1 billion. So we expect to replicate that outcome with Google and Data Collective in an even more meaningful way.
Well, that sounds great, because we were thinking about investing between all of us $2 million in the winner, and that $1 billion outcome is something that I'm sure everybody would love to see. So thank you very much.
Thank you.
And Santi.
Thank you.
Thank you. Thanks. And this brings us to the end of our keynotes for Google Cloud Next. It has been an incredible 3 days. On Wednesday, we had the opportunity to hear from Google leaders and enterprise companies that are truly engaging and building with Google Cloud and using G Suite to really collaborate in their organizations. Yesterday, we got to listen to over 24 product announcements and exciting growth areas in our products and saw demos of those. If you didn't catch them live, be sure to look at them on YouTube. And then today, I really enjoyed hearing about the open cloud community and how startups are building with Google Cloud. I want to give you a moment and a little information about some future events coming up. So we're going to be going global with Google Cloud Next, London and Tokyo, and then please save the date for 2018 back here in San Francisco. And finally, I want to thank all of you who have been here and engaging with us over the last 3 days. And a big thank you also to all of the Googlers that have helped bring this all. On behalf of everyone at Google Cloud, what really inspires us and motivates us is bringing great technology to market and thinking about what all of us can build together. So thank you very much for being part of this great conference. And I'd like to close with a photo montage of some of my favorite moments over the last 3 days. Thank you very much.